And then at the end of class, we'll look at finding the mass of the crystals. I'll talk a little bit about the post-lab, and I'll talk about Monday and Tuesday as well, because Monday and Tuesday there are no Google Meets, so it's all like asynchronous. Basically, it's work days for you guys, but I'll talk more about that in a second. So for the do now, for each of the following, draw the bond line drawings. So for this, they give us the Lewis structures of each of these. So you have all of the atoms in these, and then you need to draw the bond line drawing. So you're taking all of this, and the only thing that you show is the carbon skeleton, and then any atoms other than C and H. So if we take a look at this, we have 1, 2, 3, 4 carbons. So I'm going to actually just make it look like this because it's already zigzagged. 1, 2, 3, 4. And then the bromine is off of this last carbon. So whether you want to go up with the bromine, other people will go down with the bromine like this. As long as you have this bromine attached to this carbon by a single bond, the way that you draw it, right, bless you, doesn't actually matter. But we don't show the C's and we don't show the H's that are attached to the C's. In number 2, here we have a ring structure. So 1, 2, 3, 4, 5, 6 carbons in a ring. So we could just make it look, oh, you know, no. Wow. Hey.
It's a little lopsided.
I know. Yeah. Oh man. Okay, that's fine. It's fine. It's fine. So make sure you show your double bond. So this is in a ring, so you don't worry about zigzag for this because it's in a ring. We have a double bond here, here, and here. And then there's an OH group. So since this H is attached to the O, you have to show that one. So it's going to look like this with OH. So you don't show carbons or hydrogens that are attached to the C's, but you do need to show any other atoms. And if there's H's, you show those as well. And then for number 3, 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. And then there's a triple bond between the third and the fourth. 1, 2, 3. Right, triple bond. So as long as you are showing 5 carbons, all single bonded, except for the triple bond between 2 of them, you show that bond line drawing. And if you drew it a little bit differently, that's okay. But you should be showing the single bond and then the triple bond. So if you started the other way, you started up and went down first, that's fine. What I would be looking for in this, I would count your carbons and make sure that you have the 1 triple bond between the correct carbons. Any questions on the do now? Okay, so then we're going to switch over to the organic stuff. And while you're getting out your organic notes, I'm going to talk about Monday and Tuesday. So Monday and Tuesday, you guys are not here. It is asynchronous days for you guys because of keystones. And so Monday and Tuesday, I kind of made this like what you can work on each day. If you do everything before, right, that's fine. I haven't put the naming cycle alkanes video in Edpuzzle yet, but it's 3 minutes. So it makes up for the other 2 that were longer than 3 minutes. So I'll post reminders on the stream of Classroom each morning. You do not need to wake up for a Google Meet. All right, we will not have a Google Meet. It's all asynchronous. You do it on your own time. So this is just like what I would recommend. You want to do it all on Monday? Fine. Like, doesn't matter to me. But I just said for Monday, you're going to work on naming cycloalkanes. So today we're going to look at naming alkanes, which are just carbons all single bonded to each other. Cyclo means a circle, right, or a ring. So you're going to look at what happens if you have a ring with that. There's a 3-minute video, and then the worksheet 3 that's part of your notes packet. You'll work through that. I'll give answers. Everything will be posted on the stream of Classroom. And then Tuesday, I just said work on post-lab. So calculations, post-lab questions, and conclusion. I'll talk a little bit more about the post-lab today. I'm also going to make a post-lab video just to make sure that You know, when I talk about calculations, here's what I want to see, post-lab questions, here's what I want to see, conclusion. And then Wednesday, when everybody comes back, we're going to look at the alum lab. We're going to use a lab quiz like we've done before. Remember, it's like an open note quiz where you use your lab report to answer questions. So do you know how you took your data and did the calculations? We'll quiz on alkanes and cycloalkanes probably the end of next week. What I was looking at is giving you the choice, whether it's Thursday or Friday or Monday. Like you can pick when you take it. I have different versions of the quiz. We'll talk more about that next week. But you're probably going to have a choice. I only have one senior, so as long as he takes it beforehand, right? You guys could always take it the following Monday and be fine. It's just going to be a short quiz. It's not a big test or anything. It's going to be like what we're doing today into next week. So I'll post this Monday and Tuesday both with, here's what I want you to do, what to work on. I'm going to make the post-lab video over the weekend to post that as well. So just make yourself a note, right? It's asynchronous. You do not need to wake up. You do not need to send me a reminder at 7:30. Are we having a Google Meet? Answer is no. So now we're going to look at naming alkanes. So as we work through naming alkanes, I put a bunch of resources under the organic materials in Classroom. So like all of our units, I have a materials post at the top of that topic under the classwork tab. I did the same thing with organic. I scanned or took pictures of one of the sections of my organic textbook I had in college on naming alkanes. There's also one on naming cycloalkanes. There's a chapter from an organic help book that I put up as well. So you can look at that if you have extra questions. And then the YouTube playlist with recordings from class is also there. So there's a bunch of resources. If I find anything else, I'll put it under there as well. So kind of a what you need to know. There were some questions from the video on the prefixes as well as what a substituent is. So this alkane table is on page 8. So this is on page 8 of your notes. You need to know these prefixes. So meth, right? That is 1. Methane is 1 carbon. It's the gas that comes out of our gas jets. ETH, that's 2. Prop is 3. But is 4. And then we get into the prefixes that hopefully we recognize from naming covalent compounds. Pent, hex, hept, oct, non, and dec. These prefixes are extremely important because it tells us how many carbons we have in our longest chain. So you want to make sure that you know those prefixes. Now, substituents. A substituent is something that is connected to the longest chain of carbons. It's also called a branching group, but you'll notice that it looks similar to the parent name. So instead of methane, if it's connected to the main chain with 1 carbon, it's methyl. We drop the ANE and add YL. Or an ethyl group, propyl, 3 carbons. Butyl is 4 carbons. Now there are some different ones. So isopropyl, it still has 3 carbons, but it's connected to the main chain through one of the center carbons instead of on the end. Same thing, sec-butyl, it's on the 2nd carbon. Isobutyl and tert-butyl. We don't see these butyl ones like sec-butyl, isobutyl, and tert-butyl as often. We see isopropyl. That's probably the, I guess, weird one that we see the most. We also can see other ones. Br, Cl, F, I. We see a lot of the halogens attached. If we see NO2, NH2, those are some other ones that we'll see as well. We'll talk more about alphabetizing, but prefixes we do not consider unless it's iso. So we'll look at the alphabetical naming as we go through some examples. Now, the best way to really get good at this is by practicing. So these are on page 16. So the examples, we're going to go through 16, 17, and 18. I did the first 3 in the video. If you need to go back and rewatch those, you can. If you didn't go through the first 3, And once we go through these, you want to try them. All right, you can. We're going to start with the fourth one. So the fourth example on page 16 says, give the condensed structural formula for 1-chloro, 2-ethyl, 2-methyl butane. So now instead of naming, we're going to look at writing the formula first. So if they give us the name, can we go to the formula? Now the condensed structural formula means that we show the C's and H's together. So we're not looking at the bond line drawing. We'll look at those a little bit later. We're going to look at the condensed structural formula. So we're going to show the C's and H's. When I want to draw the structure, I'm going to start at the very end. Butane. So ANE at the end means it's all single bonds. Right? ANE means all single bonds. We are only focusing on alkanes. We are only focusing on all single bonds. We're not doing alkenes or alkynes yet. So butane, but is 4. So our parent chain, the longest chain, is 4 carbons. So I'm going to start by just drawing 4 carbons, single bonded. Now I'm going to leave some space in case I need to add hydrogens. Just going to leave a little bit of space. There's my longest chain, though, is 4 carbons. Now, when you're drawing the structure, it doesn't actually matter which way you number. I just start from left to right. So here's carbon 1, 2, 3, and 4. The numbering is important because here we see what carbons each of these groups are attached to. So off of carbon 1 is chloro. Chloro is Cl. Now, does it matter whether you make it attach up, down, or to the left? No. Doesn't matter which way, I'll make it go up. So we have a chloro group, Cl, attached to the first carbon. On the second carbon is an ethyl group. F means 2 carbons. And so what that is it's CH2, CH3. It's 2 carbons together. Because ethane is 2 carbons single bonded. So an ethyl group, just the YL, means it's attached to the main chain. So I'll do it straight down this time. Be careful when you're showing your substituents because this carbon is single bonded to the carbon. Then I'll do CH2, CH3. So we have carbon single bonded to this carbon, right, CH2, CH3. This is condensed. We're not showing every hydrogen off of the carbon, we're condensing it down. And then also off of the second carbon is a methyl group. That's CH3. The reason that it's CH3 and not CH4, CH4 is methane. Well, it has to be single bonded. If 1 carbon is single bonded, it only needs 3 more bonds. So a methyl group is CH3. Again, I put it on the second carbon because the numbers here tell me what carbons each are attached to. Now the only thing left is to add the hydrogens. Right? Add the hydrogens to these carbons in the chain. This carbon 1 has 2 bonds, it needs 2 more. Now you could show the H's here. You could do CH2. Sometimes you'll see it written like this on the outside, just to show that this carbon is single bonded to the Cl and to the C. If you were to show the H2 on this side, that's also fine. This carbon already has 4 bonds, doesn't need any more. This carbon has 2 bonds, it needs 2 more. So I'm going to show the CH2. So basically, instead of having an H on top and H on bottom, we're condensing them together. That's the condensed formula. And then this carbon on the end has 1 bond, it needs 3 more. This is our answer. This is our condensed structural formula for 1-chloro, 2-ethyl, 2-methyl butane. So start kind of working backwards. Start with your parent chain and then go back and add all of your substituents. Questions on this one? As we go through, if you have questions, just stop me as we're going through these. So we just drew a structure. Now we're going to look for the name. So here is a compound given to us, and it says give the name for this compound. Well, some steps to go through. The first thing you always want to do when you're naming. Now, these are all alkanes. So we don't have to worry about different functional groups. We don't have to worry about OHs. We don't have to worry about carboxylic acids. These are all alkanes. So the first thing we do when we're naming alkanes is look for the longest chain. So if I start here, 1, 2, 3, 4, 5, right? So there's a 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. All right, so sometimes your longest chain might not be in a straight line. As long as it's a continuous chain of carbons, it might turn. 1, 2, 3, 4, 5, 6. That's our longest chain. So this is the longest chain. It has 6 carbons. What's the prefix for 6? Hex. So our parent name is hexane. So we're going to end this with hexane. Now, we have 2 substituents, 2 groups off of the parent chain. When you have groups off of the parent chain, you have to number the carbons in the main chain so that you can tell whoever's reading this name exactly where they are. When you number the carbons, start with the 1 on the side closest to a substituent. So what that means is if I start here, I'm not close to a substituent. If I start here, there's a substituent on the next carbon. So I'm going to number it this way. 1, 2, 3, 4, 5, 6. You're numbering your carbons in the main chain. So now once I have those numbered, I like to label my substituents, what groups are off of the parent chain. A 1-carbon group. A 1-carbon group is a methyl group. 1 carbon is meth. It's attached to the parent chain. You had the YL. The 4th carbon has a methyl group. When you have the same substituent, so we have 2 methyl groups. When we have the same substituent, we can use prefixes. Di, tri, tetra, penta. What's the prefix for 2? Di. So here we have dimethyl. Now you always start the name with the numbers where the substituents are. I have a methyl group on carbon 2, and I have a methyl group on carbon 4. When you're separating numbers, you use commas. So we're saying that we have something on carbon 2, something on carbon 4, and then between numbers and letters, we use dashes. So on carbon 2 and carbon 4, we have a methyl group. So it's dimethylhexane. This is all actually one word. I just had some space. So this is 2,4-dimethylhexane. So again, that tells us that dimethyl means we have 2 methyl groups, 1 on carbon 2, 1 on carbon 4. So it's almost like a map. You're showing the person that's writing this where everything is. So you start by finding the longest chain and then kind of go from there. Take a look at this next one. Always start by finding your longest chain. So you count through. So now we're on page 17. Count through. Right? You can go in a straight line, count that way, see how many carbons you have. You could start at the top and go down. But if you count through this way, I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I have 6 no matter what. So I'm just going to use this straight line of carbons. Doesn't actually matter which way you go. You could use this carbon and gone this way. Your name's going to be the same. So again, 6 carbons. So that's hexane. So my parent name of this is hexane. And then off of a carbon, again, I have 2 substituents. Number your carbon chain so that these substituents have the lowest number possible. If I start from this side, it's 1, 2, 3, 4, 5. This carbon would be 5. If I start closest to the substituents, it's 1, 2. So the substituents are off of the second carbon. That's the way you want to number it. Now with this, you have to be careful because if you have more than one substituent, you need more than one number. So for this, CH3 group is methyl. CH3 group is methyl. I have 2 methyl groups again. So we know from before, 2 methyl groups is dimethyl. When we give the numbers, you have to give as many numbers as substituents. So if I have 2 methyl groups, I should have 2 numbers at the beginning of the name. Both methyl groups are off of the second carbon. So I'm going to do 2, 2. Because that tells me that even though I have 2 methyl groups, they're both off of this second carbon. So then we will have dimethyl hexane. That's what our name will look like. 2,2-dimethyl hexane. Because there's a methyl group here and here, so since there are 2 methyl groups, we'll do dimethyl. Yep. If we take a look at this next one, see if you can find the parent chain. So first, see if you can find the parent chain and see if you can identify the substituents. So can you figure out what the longest carbon chain is? And then how many and what type of substituents are off of that chain? No matter which way I count, I have 5 carbons in the longest chain. I see that there are 3 substituents off of this carbon chain. Number so that your substituents have the lowest number possible. This one can be a little tricky because no matter which way you start, there's a substituent off of the second carbon. I'm going to actually choose to number this way. Here's why. Because this way, 2 of my methyl groups have the number 2. If I went the other way, 2 of the methyl groups would have the number 4. You want the lowest numbers possible. Now, all 3 of these are methyl groups. All right, all 3 of them are methyl groups. So let's start by just writing the numbers that all of the substituents are attached to. So I have a methyl group on carbon 2. I also have a methyl group off of this carbon 2. And I have a methyl group off of carbon 4. So I'm listing the numbers of the carbons that the methyl groups are attached to. There are 3 methyl groups. When you're thinking about prefixes, not the carbon prefixes, but just prefixes for numbers. What's 3? Tri. So since there are 3 methyl groups, it's trimethyl. And then the longest chain of carbons is 5. So it's pentane. 2,2,4 trimethyl pentane. Now we've been looking at these that all have the same substituent. They've all been methyl. We're going to look at what happens when we have something besides just methyl groups attached. So let's look at this. Again, start by finding the longest chain of carbons. go in a straight line, but also if the carbons can turn, check that as an option as well. The longest carbon chain is not always a straight line. So if I look for the longest carbon chain, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, well, the longest here is 6. So no matter which way I do it, my substituents will be the same, so I'm just going to go this way. There's my longest chain, 6 carbons. 6 carbons all single bonded together. Mean that the end of this name will be hexane. Now we have to figure out which way to number. Start with the 1 closest to a substituent. All right, start at the end closest to a substituent. That's going to be this side. 1, 2, 3, 4, 5, 6. Now, what I like to do is name the substituents. CH3 group, that's a methyl group. Has 1 carbon. Off of carbon 4, we have 2 carbons attached to each other. Well, we know that 2 carbons single bonded is ethane. So if it's attached, you drop the A and E and add Y up. So this becomes an ethyl group. Now, when you write the name, you do not do it in numeric order, you do it in alphabetical order. So which of the substituents is going to come first alphabetically? Ethyl. Ethyl comes first alphabetically. So we're going to use the 4 because that's the carbon that it's attached to. There's only 1 ethyl, so we only have 1 number. You separate numbers and letters with dashes. So 4 ethyl. Then we have another substituent, so I'm going to use another dash because we're separating letters and numbers. 2 methyl, and then add the parent name. So 4 ethyl, 2 methyl hexane. You name the substituents in alphabetical order, not numeric order. Questions on this one? So see if for the next one you can find the parent chain.
Why is ethyl written as CH2 and then CH3? Why isn't it C2H?
They're just showing the connectivity. They could write it as C2H5. They're usually going to show it like this, just to show you that the carbons are single bonded. Yeah. So for this one, find your longest chain of carbons. This one finally is not a hexane. Right, so you're counting your longest chain of carbons, and now you might need to look back at your substituent table to see what one of these substituents is. One that we don't see as often. All right, so okay. So this is my longest chain of carbons. Because 1, 2, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, if I go up. So my longest is 8. 8 carbons with all single bonds is what parent name? Octane. So we're going to end the name with octane. Now we have 2 substituents. Here's one of the groups that's attached to a carbon. Here's the other group that's attached to a carbon. We've seen CH3 a few times now. We know that's a methyl group. This one's a little bit different. This has 4 carbons. So we know that it's going to be some sort of butyl group. The reason that it's not just butyl is because if it were just butyl, it would be 4 carbons in a straight line. Well, if you look back at the substituent table, so the substituent table is on page 13. This one where you have the center carbon attached to 3 other carbons, this is called tert-butyl. Again, this is one we don't see as often, but it's important to be able to look at that table to recognize substituents. Now, when we name, the only prefix that we include in alphabetizing is iso. This tert is considered a prefix. So when we're alphabetizing, we're looking at butyl versus methyl. Now again, we have to number. We need to know what carbons these are on. If I start from the left side, this is the 5th carbon. If I start from the right side, this is the 4th carbon. You want the lowest numbers possible. So I'm going to start from the right in numbering. So both of these are attached to carbon 4. This tert-butyl is actually going to come first because the tert is a prefix. So on the 4th carbon, there is a tert-butyl group. So it is 4-tert-butyl. When you're separating numbers and letters, you use dashes. So then we're going to have another 4 because the methyl group is off the 4th carbon as well. The only time that you use commas is when you're listing the numbers that all the same substituent describes. So this is 4-methyl octane. So find the parent chain, look at the substituents that are attached, number the carbons to make sure that they have the lowest numbers possible. Questions on these? Okay, now it gets to drawing. So if you like drawing, we're going to draw some bond line drawings. Now we're on page 18. So now we want the bond line structure for 4-isopropyl 2-methylheptane. So bond line drawing, that's like what we did in the do now, zigzags. So now they give us the name, you have to go to the structure. Start at the end of the name first. End of the name, heptane. Hep is how many carbons? 7. Remember, as soon as your pencil touches the paper, that's 1 carbon. So 1, 2, 3, 4, 5, 6, 7. It's not the number of lines, it's the number of endpoints and corners. 1, 2, 3, 4, 5, 6, 7. I always double check. So there's my parent carbon chain. So now we have 4-isopropyl and 2-methyl. So number your carbons. Doesn't matter which way you start numbering. If I'm drawing the structure, I just start left to right, but it's up to you. Plus, that makes sure that you have your correct number of carbons. So 4-isopropyl. So off of the 4th carbon, we're going to have an isopropyl group. The isopropyl group, so propyl means 3 carbons. So it actually looks like this on your substituent table. It's 3 carbons, but it's attached to the main chain from the center carbon, not from the end. It's not a straight line. That's why it's not just propyl. So if it looks like this, I'm going to draw a line up. So now that's connected to this carbon. I need 2 more carbons on each side to make it look like that. This is 3 carbons attached to each other. And that isopropyl group is attached to the main chain through the center carbon. Then 2-methyl. So then off the 2nd carbon, we have a methyl group. Just a single line represents a methyl group. It's just CH3. There's your carbon at the end. This is your bond line drawing for 4-isopropyl 2-methylheptane. So see if you can work through the next one. See if you can use what we just did to draw the bond line structure for 1,1-dichloro 3-isopropyl 2-methylhexane. So start backwards. Draw your parent chain first. Then look at all of your substituents. So that's what my bond line drawing looked like. Now the way that you drew the CLs, as long as you had both CLs off of the first carbon, whether you had up, down, right, one off to the side, you just needed both of these carbons. This shows single bonds to this, both of these chlorines are single bonded to this carbon off of the first, methyl group off of the second, isopropyl group off of the third. Notice how this name is written. Chloro, right? Di doesn't count in the prefix. Chloro came first. Iso counts, so I, and then M. It's not numeric, it's alphabetical. Yeah.
Why are there 2 ones in this one?
Because since both of these chlorines are on the first carbon, even if they're on the same carbon, you need as many numbers as substituents. So the 1,1 tells you that dichloro, you have 2 CLs. They're both on the first carbon.
But wouldn't you get the same thing with 1,1 because it's chloro?
Would you? Yes. But they always say you need as many numbers as substituents. Which is why, like when we had the one question, it was 2,2-dimethyl. You still needed both 2s because that's just showing you where they are. Yeah. Yeah.
The iso one up too,
Like here.
or should it go down?
So you could do it up.
Oh,
You
it
always
seems like
just want it
one-
as far apart as possible.
Okay, so one-
So typically if you have something at the bottom point, you're going to make it point down. At the top point, you would make it point up. Is it wrong if you did it up? No. It just helps to separate it as much as possible. So now what we're going to do, so the last 2 questions, we are going to try to name based on the bond line drawing. So we're trying to look at writing names, whether we have the condensed or whether we have the bond line drawings, just to be able to focus on any types of formulas. So the name for the compound represented by this structure. So again, the first thing you want to do is find the longest chain of carbons. 1, 2, 3, 4, 5, 6. 4, 5, 6. All right, so either way you go, it's 6 carbons. I'm just going to use this. I'll just outline it. I'm going to use that as my main chain of carbons. This one line down represents 1 C. All right, so there's 3 H's. This is a methyl group. When you number your chain, start the numbering closest to the substituent. So start on the end closest to the substituent. That's this side. 1, 2, 3, 4, 5, 6. So now when we name this, there's only this one substituent on the second carbon. So 2 methyl, and then what's the parent chain? Hexane. That's 2-methylhexane. And then the last one. Last one's a little tricky because of the way that our longest chain goes. But if we take a look at this, so we have this bond line drawing. Remember, find your parent chain first. Find the longest chain of carbons. You might need to go in different directions, but when you're looking for the longest chain of carbons, it's the longest continuous chain of carbons. So you can't stop and say, oh, look, there's more over here. Has to be a continuous chain. So 1, 2, 3, 4, 5, 6, 7. So there's 7 if I go straight across. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Or what if I go 1, 2, 3, 4, 5, 6, 7, 8? Or 1, 2, 3, 4, 5, 6, 7, 8. So I see a long chain of 8 carbons. Now, if I start this way and number, that's going to give me this weird looking substituent. You want to find the parent chain, the longest chain of carbons that gives you the most substituents. So if I use this as the parent chain, that would only give me one weird looking substituent. If I started this way and worked down, that would give me 2 different substituents, 2 groups off the main chain. So I'm going to use this one as the main chain. Now, when I number, you want to start your numbering at the end closest to a substituent. That's this end. There's a substituent right here. 1, 2, 3, 4, 5, 6, 7, 8. And so I notice here, right off the third, it's a single bond to a carbon. That's a CH3 group. That's a methyl group. Off the 4th carbon, there's a substituent. Off the 4th carbon, there's 1, 2, 3 carbons attached at carbon 4. Now, what I want you to focus on is how these 3 carbons are in a straight line. Here's a carbon, here's a carbon, here's a carbon. They're all attached in a straight line. Remember the difference? Isopropyl that we saw was connected like this. So even though it was 3 carbons, it wasn't in a straight line. If you have carbons attached in a straight line, that's based on the parent names. 3 carbons, all single bonded as propane. If they're attached to a main group, it's propyl. So now when we name this, we have something on the 3rd, something on the 4th. Make sure you're putting it in alphabetical order. Methyl comes first. 3 methyl, 4 propyl. Notice how dashes separate letters and numbers. After your last substituent, you add the parent name to the end. 8 carbons, all single bonded, octane. 3 methyl, 4 propyl octane. So it's just kind of finding the longest chain, kind of problem solving to figure out which way should you start numbering. And then finding the substituents. These are all going to be alkanes. They're all single bonded. So it should always end in ANE. If there was 1 double bond, this would end in ENE. And if there was a triple bond, it would end in YNE. So that's actually it for the examples. I'm going to talk just a minute about the post lab. And then after the post lab, there's going to be some time to actually work on it's organic worksheet 1 and 2. So at the end of your notes, there's actually 3 organic worksheets. 1 and 2 is alkanes, 3 is cycloalkanes. So we haven't gotten there yet. But before you go into the lab, just some things with post lab. I'll talk about this when I post on the stream for Monday and Tuesday. You will have 3 sections for post lab: calculations, post lab questions, and conclusion. Calculations, I want to be its own section. It's actually number 8 from the post lab, but you're not going to do it in the post lab question. So if you want to make yourself a note on the lab handout, number 8 is going to be its own section. So do the calculation section first. You're going to have 2 calculations, theoretical yield and percent yield. So don't forget to label the calculation. So label theoretical yield, and then that's like number 6 from the pre-lab, except start with your mass of aluminum, not potassium. And I'll put this slide on the stream when I post everything. And I'll talk a little bit about this when I make the pre-lab video. And then you'll have percent yield. That's like number 7 from the pre-lab, but you're going to use your data. So what mass of crystals did you collect versus your theoretical yield times 100. Then you'll have your post-lab questions. Just number them in your lab notebook. Number 1 is looking at net ionic equations. So number 1 gives you reactants and products. You just need to determine the formulas and then make it net ionic. So by making it net ionic, break apart strong bases and soluble salts. Cancel out spectators. Don't forget to balance. Number 3 is asking for sources of error. So number 3 of the post lab is just asking, why did you not collect 100% of the crystals? So what sources of error did you maybe have? If you were like, I'm not sure, think about what could have happened. Did you get all the crystals out of the beaker yesterday when you filtered? Right, things like that. Did some splash out? Some of the post-lab questions you might need to look up, like the shape of an octahedron, if you're not sure what it looks like. And then conclusion, purpose, did you fulfill it, why or why not? So you'll have 3 sections for post-lab. Calculations are short, it's 2 calculations, post-lab questions, and then conclusion. So if you want to start now, you can. But for the rest of class, you're going to measure the mass of your crystals. So your crystals, use a scale, right? Find the mass of your crystals. Then I would actually suggest working on organic worksheet 1 and 2 first. I will have the post-lab video made for you. I'll do it over the weekend, or I'll do it 8th period today, where I'll actually kind of walk you through. So I would hold off on the post-lab. You'll have time next week, like Monday, Tuesday, so those asynchronous days to work on it. So then work on worksheet 1 and 2. Whatever you don't get done in class, just try to finish them over the weekend just to practice. I have the key here. I also have worksheet 1, the answer key is here. Worksheet 2, the answer key is here. You'll notice that there are 3 pages for each, because for the second page, you're actually drawing the structure. And what I did is I drew the bond line and I drew the condensed. So whichever one you want to do is up to you. If you want to mix it up a little bit, but I have both of them just in case. So if you want to take a break, you can take a break. But then when you come back, measure the mass of your crystals, right? Work on this stuff.